Acceleration in electric fields. In this video, we'll be looking at calculating the energy of a charge that's in an electric field, finding the acceleration of a charge in an electric field, which in turn will allow us to describe the motion of the particle in the field. We can calculate the field strength of a uniform electric field by considering a charge that moves between 2 points. So we can see in the diagram on this slide that the field is uniform in strength because the field lines are equally spaced, and we're going to consider the potential difference between points x and y to be delta V. Now the force in the field is given by F equals the electric field strength times Q, which we know from previous lessons. By definition, the work done by this charge or on this charge when it moves through the field is the charge magnitude times the voltage that it passes through. But from stage 1 physics, we know the definition of work is the force times the distance. So the force times the distance is the same as the charge times the voltage that it moves through. So they're both the same value. So we're going to equate these two. And you can see that we're equating them here. And if we substitute electric field strength times charge being force, we result in this equation here. And we can simplify it further, finding that the electric field strength is the voltage divided by the distance that the particle moves through. So this is great for determining the electric field strength between two plates, and it also provides us for new units of electric field strength. So when we're looking at a uniform electric field, the force experienced by a charge in the field is given by the electric field strength times the charge. And being a vector equation, what that means is if the charge is positive, the direction of that force is the same with the field. If the charge is negative, the force is in the opposite direction of the field. And if the field strength is constant, so is the force. Now that constant force is important as it relates to constant acceleration, which allows us to use our equations of motion. So using Newton's second law, F equals ma, a charge will experience acceleration if it is free to move. So if we know the force on a charge in an electric field is given by EQ, and force is also ma, we can equate these two, which results in the acceleration of a particle in an electric field can be calculated by the electric field strength times the charge divided by the mass of the charge. Now this allows us to use our equations of motion for motion topic. However, it's one extra step. Typically in motion we were looking at gravity and acceleration due to gravity. However, in this topic we might need to calculate the acceleration in each individual question before we can continue. Typically in stage 2 physics, there are two types of problems that they can ask you relating to electric fields. And they're questions relating to kinematics or motion, or those that are related to energy. So have a look at the formula sheet in this section of electric fields, the formulas for motion and energy. And based on the question that you have, the best way to do it is to write down what you know, find an equation that fits, and then solve it from there. I do have a little bit more detail in going through examples in a video I made previously, so I'll provide the link in the description below. So when discussing motion in an electric field, we can actually compare it to a gravitational field. In a gravitational field, the force of gravity is going down towards the center of the earth. Now in an electric field, our force will be again in one direction, and there will be an acceleration of the particle in this direction only. At right angles to this force, since there are no other forces, the speed of the projectile or the object will remain constant. If we consider this scenario over here on the right hand diagram, this electric field is going down. We can compare that to gravity going down. If we had a positive charge, because the positive charge will follow the electric field lines. If we had a positive charge and we launched it horizontally, it will behave the same as a projectile in gravity, and undergoing constant acceleration will have a parabolic arc. If the separation distance between two plates was increased, how would this affect the electric field? When answering a question like this, see if you can find an equation that can assist.